All right. Good evening, guys. Happy Tuesday. We meet again. And this week I feel much better. Not sick this week. Hey, so I sound a bit better today. So this is our lesson for April week 2. Okay. Guys, just a reminder, next week will be our last class before we go for holiday. You guys know this? You guys know this? That means, okay, just a quick announcement. Next Tuesday class is as usual. Okay. And then next Tuesday, which is 25th of April, is our holiday. All right. And then following week, when we come back for May, that would be our April week 4. Just to let you know in advance, I mean, next week I'll tell you again. But this week is week 2, next week is week 3, the following week is holiday, and then the next week is week 4. All right, so we did not skip a week as usual. Our TDC, our holiday, it's not that we skip 1 week. Okay, every month has 4 weeks, so everything is still as normal. Okay, so anyway, we are in chapter 5. Okay, chapter 5. This is the second week of April already. So I believe you have your notes. Do you? Do you have your notes? Do you have your notes? For those who just joined, Yinghui, do you have your notes? This is April notes. Okay, when you first joined, okay, last week was your first week, right? So when you join, I think you have this already. You think no, bah? You don't have this note, have you requested when you sign up? Did they send you a link for you to request? So they should, and when you request, they should send it to you already. Any one of you here don't have the notes? Okay, any of you don't have the notes? That means you guys have the notes, You guys have the notes, besides Yinghui here. The rest of you have your notes, Okay. Anyway, let's begin with chapter 5. Okay, this is a very simple chapter. I will finish this in 1 day. All right, I'll finish this in 1 day. Why? Because this is a very simple chapter. All right, so let's talk about energy change. Let's talk about energy change. So this is a continue of last chapter. Last chapter, we learned about atoms, right? We learned about chemical reactions, right? So this chapter is also chemistry. We talk about energy change. All right, so there are two types of energy change. There are two types of energy change. Okay, so when you do a reaction, okay, let's say this is a chemical reaction. When you do a reaction, the surrounding, either it becomes hot, okay, either the surrounding becomes hot or the surrounding becomes cold. Any of you learned this in school already? Any of you learned this in school already? When your surrounding becomes hot, we call it exothermic reaction. There's a reaction missing here. And if the surrounding becomes cold, we call it endothermic reaction. Oh, year 8. Okay, okay. Okay, some of you, I think, learn it in year 8 already. Because according to Cambridge syllabus, this should be in year 9. I don't know okay, because every school is different. All right, every school is different. Okay, any of you learned this before? Besides, oh, so Marcus, you learned this already, Anyone else? Have you guys learned this before? Okay, this is very easy, So for those who learn it already, this is pretty easy, isn't it? Oh, Ethan, you also learned it already. Okay, so I'm just gonna speed this through. Okay, so how do you memorize this? Very easy. Okay, you see exo. Exo stands for exit. Endo stands for enter. Heat enters the reaction, heat exits the reaction. Okay, so you have exothermic and endothermic. So in exothermic, okay, exit and thermic is heat. Next time when you go chemistry, when you go year 10 and year 11, you will learn back the same thing again. All right, so in exothermic reaction and processes, heat energy is given out. Okay, heat energy is given out, released to surrounding. In endothermic reaction, endo is enter, exothermic is heat. That means heat enters the reactant. Okay, enters the reaction. Okay, heat energy is taken in. That's it, lor. That's it, lor. That's the chapter, lor. Right? Exothermic, heat goes out, surrounding becomes hot. Endothermic absorbs heat, surrounding becomes cold. That's all. Right? That's why this chapter, it's kind of stupid because it's like differentiating between left and right. Right? Between up and down. So it's really, really simple. Really, really, I wouldn't say pointless lah, but it's really simple, okay? Guys, please don't get this chapter wrong. It will be very embarrassing if you get it wrong. Hello, Felice, how are you? I just finished the main point, then you came in. Okay, so again, so you have exothermic and endothermic. Felice, have you learned this before? Have you learned this before? Exothermic is heat exiting the chemical reaction. Endothermic is heat entering. So surrounding becomes hot, surrounding becomes cold. All right, so let's look at this. So in exothermic, heat energy absorbed into the system is less than the heat energy released into the surrounding. So I release energy more than I absorb, so the surrounding becomes hot. Surrounding temperature increase, rise in reading of thermometer. So if I put a thermometer here, the surrounding will become hot. You touch the cup, it becomes hot. All right, so endothermic is the reverse. Heat absorbed is more than heat released. So I absorb heat more than releasing heat. So the surrounding temperature decrease. Okay, surrounding becomes cold. Drop in the reading of thermometer. So surrounding becomes cold. Okay, okay, this is very easy concept. Okay, you know your fridge. You know your fridge. Your fridge is exothermic because around your fridge, I'm talking about outside. You touch the outside of your fridge, it feels hot, right? Because it's exothermic. But inside your fridge, your food is doing endo. Okay, because they absorb the heat. Your fridge is doing endo. It absorbs the heat, so your food becomes cold. So it's like the reverse. All right, your inside your fridge absorbs heat. Outside your fridge release heat. So inside is endo, outside is exo. Very simple. Okay, so let's talk about exothermic reactions. Okay, I'm sure you already know this. Guys, don't fall asleep. I know this is very easy, but still, next time when you go year 10, you will be calculating this thing. All right, yes, there's calculation for exo and endo, but you're not learning it right now. You learn it in year 10. All right, so what is exothermic reaction? Exothermic reaction, okay, one of it is burning. All right, just ask yourself, does it become hot or cold? When you burn something, your surrounding gets hot, right? So this is exo. Right, so the exothermic reaction that is most familiar to everyone is combustion or burning. You can call it combustion or you can call it burning, whatever. Many substances are burned to provide heat or light. They are called fuel, right? So guys, pay attention to this fuel. Fuel. This one in Mandarin is called 燃料。你烧东西会出热能嘛，所以你烧的那个东西就是燃料咯。The thing you burn is fuel. The petrol in your car, your wood, coal, charcoal, whatever they can burn. Even a piece of paper is fuel. Because you burn paper, you get fire, you get heat, right? So that's your fuel. Okay, so these are your fuel. So you have wood, as in kayu, mu. You have coal, as in 煤炭. You have coke. You might say, sir, what the hell is Coke? I thought Coke is Coca-Cola. Okay, no, Coke is this thing. Oh my God, why is this showing me this? Okay, Coke, Coke fuel, sorry. Okay, Coke fuel. All right. It kind of looks like charcoal or coal. You might say, sir, isn't it the same? Coal is a bit darker. Coal is a bit blacker. It's almost the same thing, lah. Okay, it's almost the same thing. So that's your coal. That's your coke. Okay, and then you have your charcoal. We use this for barbecue. Oil, diesel, petrol, natural gas, wax. They are all examples of fuel. Okay, you use your wax in your candle. Okay, your wax burns candle. Wait, your candles burns wax. What am I saying? Okay, your candles burns wax. So it's a fuel. All right. So the heat may be used to warm buildings, cook meals, make chemicals in industry, and turn water into steam to drive generator in power station. Guys, we learned this in year 7, right? We learned this in year 7, right? When we use fuel to generate electricity, we use fuel and we burn water. Water turns into steam. Steam will spin the generator, right? It will spin the generator. We get electricity all the same. All right. I don't care you burn coal or you burn coke, you burn charcoal, you burn anything, you burn petrol, anything. The job is to heat water and use water to turn the turbine, turn the generator. 发电机用蒸汽来转发电机，就是发电的原理。Okay, and some gases, oil, and waxes are burned in lamps to provide light. Okay, we burn this to provide light. So let's talk about hydrocarbon. Okay, let's talk about hydrocarbon. Hydrocarbon is a type of fuel made of carbon and hydrogen because the name hydrocarbon. Hydro means hydrogen, carbon means carbon. Water energy, you mean kinetic? Because your water turns into steam. Steam can move, right? A moving energy is called kinetic. Are you asking about that? So that's your kinetic energy. All right. And of course, guys, pay attention to this fossil fuel. Fossil fuel. Fossil fuel, we have three. We have natural gas, the gas your mom used for cooking. Okay, the gas your mom used for cooking. And we have petroleum, 石油, the one you put in your car. And we have coal. Coal, what is coal? Hi, Terence, how are you? Okay, what is coal? Coal is this thing. Many countries, they use this thing to generate electricity. 很多国家是用煤炭来发电的. Do you know this? Like China, they use coal. China, they use coal. Malaysia, we don't use that much coal. We use around 20-30% of coal. But China is like 60-70% coal. Right? Why do we still use coal? Because coal is very cheap. It's okay, as long as you're here. So coal is very cheap. Coal is really cheap. That's why we use coal. All right. So fossil fuel, so it's an example of hydrocarbon. Guys, I think I talked about this in pollution. We are still using 80% of fossil fuel today. That means all the energy around you, your electricity, your transport, your factory, everything, 80% of the energy still comes from fossil fuel. So is fossil fuel very important? Very. 我们华语叫石化燃料。Okay, 石化燃料。Okay, this thing is very important. 很重要。We are still 80% reliant on it. Okay, so you might say, sir, since fossil fuel is very bad for the environment, right? Why are we still using it? Because we have no choice. We have no choice. Fossil fuel is not something you can replace easily. How do you replace 80% of something? Right? If you say, sir, we don't want to use fossil fuel, can. Then what are you using? What are you using? You see? So that's the problem. This is the biggest problem we are facing right now. I mean, you can use solar, you can use nuclear, but still fossil fuel is the best. Many countries will still use fossil fuel. All right, so next, when fuel burns, carbon dioxide and water are produced. This process gives out heat energy. So this is your combustion. This is a combustion. So you have fuel plus oxygen because you need oxygen to burn, right? You get carbon dioxide and water and energy. This is what your car is doing. 你的车就是在做这个东西. Your engine is doing this. That's why your exhaust, you know your exhaust, your car behind has an exhaust pipe, right? 车的后面不是有一个排气管的. Okay, so you put your hand there. You should feel air coming out. That's your carbon dioxide. And after, okay, you can go home and try. You put your car at the exhaust. Don't touch it. It's very hot. Don't touch it. You put your hand there. After for 10 seconds, you feel your hand. It should feel moist. Okay, 放你的手在那个排气管放10秒，你会 feel 你的手湿湿的。Okay, it's wet because there's water. All right, so whenever you burn something, you will get water. That's one of the byproduct. That's one of the product you get. That means even when you burn candle, even burning candle, you get water. Very little, you won't see it, but very, very little. So fuel plus oxygen, you get carbon dioxide, water, and energy. Okay, you guys cool, huh? You guys cool, huh? This is a very easy chapter, so I'm just gonna go through quickly. So incomplete combustion. Okay, guys, what happens when you don't have enough oxygen? When you don't have enough oxygen, if there is insufficient oxygen to support complete combustion, incomplete combustion takes place. So when there's not enough oxygen, instead of getting carbon dioxide is CO2, Now you only get carbon monoxide. You have one oxygen missing. You have one oxygen missing, and you also get some carbon. This carbon becomes your soot. You know what is soot? 我们叫做，我不知道华语叫什么嘞。你烧了东西黑黑的那个灰啊 ，this thing is called your soot. You see, soot. This is incomplete combustion. Happens in old cars. Okay, happens in old cars. You know what is carbon monoxide, guys? 你懂这个是什么吗？一氧化碳。Do you know what is carbon monoxide? Carbon monoxide is poisonous. Okay, this thing is poisonous. Right? When you smell this thing, you will die. Right? So this is one of the way people kill themselves is by closing the doors and windows. They burn charcoal in a room. 所谓的烧炭自杀就是这样。Inside car also got, yes. That means you stand in a room. If I start burning, okay, let's say this is charcoal. I start burning charcoal. I will produce carbon monoxide. I will die inside. I will die inside. Okay. You know some K-pop stars, they kill themselves this way. You know who is Shiny? You know who is Shiny? There's a K-pop group called Shiny. One of the member called Jonghyun, he died because of this. He died by burning charcoal, right? Because he had depression and he couldn't get over the depression, so he killed himself by using this, right? So this is incomplete combustion. Incomplete combustion. So carbon monoxide is a very dangerous chemical produced by incomplete combustion. It is produced in car engine and is released in the exhaust fume. So in your car exhaust, you will get a little bit of carbon monoxide. All right. So carbon monoxide, why is it so dangerous? Because it is colorless, it is odorless, so you do not know when it is being produced. Right? When you smell carbon monoxide, you cannot feel anything. If it is breathed in, it stops the blood taking up oxygen because it binds strongly to hemoglobin. This might lead to death. Guys, you remember what is this? You remember what is hemoglobin? In Mandarin, we call it 血红素, 你的血红素. So hemoglobin is to carry oxygen, right? To carry oxygen to your body. When carbon monoxide binds to hemoglobin, carbon monoxide will not let go. Carbon monoxide will not let go. 一氧化碳不会放它走. So now your red blood cell is useless. Your red blood cell is with carbon monoxide already. So your red blood cell cannot carry oxygen. So you die. So you die. So this is why they say, guys, have you heard of this? Have you heard of this? They say do not sleep in your car while the engine is running. Have you heard of this before? I mean, if the car is moving, it's okay lah. If the car is moving, it's okay. But you don't sleep in a car with the engine running and you stop somewhere. This is how you get carbon monoxide poisoning. Have you guys heard it before? Have you guys heard it before? If you need to sleep, please don't sleep in a car. Please don't sleep in a car because your car will produce carbon monoxide and your aircon will blow the carbon monoxide into your car and you smell it, you sleep inside, and that's how you die. Same thing as burning charcoal here. Same thing as burning charcoal in a room. Guys, case in point, this thing really happened. I think 2-3 years ago. 2-3 years ago, there were these three Malay girls. They went to some kind of road trip. Okay, they I don't know where they went lah. Okay, 3 of them were in the car, and at night, right, they couldn't get a hotel room, so they say never mind lah. They just park their car at a petrol station. I think they park their car at a petrol station and then they just sleep in the car. Right, they sleep in the car, and the next day when people discovered them, they broke their window and open it so that they pull them out, and 3 of them, 2 died, 1 got into a coma. Okay, yes, okay, so so did Felice, did I explain last time? Did I explain this last time? Yes, okay, so your carbon monoxide, right, plus your hemoglobin, okay, this is just to tell you, carbon monoxide plus hemoglobin, you will get something called this is called carboxyhemoglobin. Can you see? Now the carbon is bind to this hemoglobin. This thing is very stable. This carbon monoxide will not let go. Imagine this is hemoglobin, this is carbon monoxide. Carbon monoxide will bind to the hemoglobin and they will not let go. So now oxygen has nowhere to go. oxygen cannot bind to the hemoglobin, so the hemoglobin is useless. So you will slowly lose oxygen and you slowly die. It's a slow and peaceful, I guess, death. So if you ever want to kill yourself, I mean, please don't do it lah. I mean, if you want to kill yourself, the most painless way, it would be burning charcoal. Right? That's why many people choose this way, because it's painless, right? Or they just sleep in their car. They want to kill themselves, they sleep in their car. Okay? Unless you drive a Tesla lah, guys. Unless you drive a Tesla. If you drive a Tesla, you can sleep in your car because Tesla has no combustion. Tesla doesn't need petrol, so you can sleep in your Tesla for anytime you want. All right? Can't walk away. Here's the thing. You won't know this. You won't know this, right? Okay, how do you know? Okay, guys, just a tip for you. How do you know you get carbon monoxide poisoning? 你怎样知道你一氧化碳中毒嘞？ You feel dizzy. You feel lightheaded, you feel dizzy, you feel okay. When you lack oxygen, what do? You yawn, right? You yawn and then you feel dizzy, you feel lightheaded. That's a very big sign that you are having carbon monoxide poisoning. Okay, so faster run away. Okay, but it's very hard to know lah because it has no smell and it has no color, so you don't know. Okay, I mean you shouldn't be in the position lah, but good to know. All right, so measuring energy in field. So which field has the most energy? Which field has the most energy? The energy in the field can be found by collecting the heat energy released from a burning field and measuring it. Okay, so how do we measure field? We measure field using this thing called calorimeter. Calorimeter. We burn this thing and we measure the temperature. You know what is a calorie? Guys, do you know what is a calorie? For you girls, I'm sure you girls care about diet, right? Okay, maybe you don't, but most girls do, right? You care about calorie, right? Oh, I shouldn't eat this because it has a lot of calorie. It will make me fat. Calorie is to measure energy, right? You know your food packaging, it says there, oh, 2 pieces of bread gives you 200 calorie. Calorie lo. Right? This is how you get energy lo. So okay, so which field gives you the most energy? Which field gives you the most energy? Let's look at here. Let's look at here. Okay, see, natural gas gives you 56. Okay, oil gives you, this is per gram. This is per gram. So oil gives you 48. Coal gives you 34. Coke gives you 32. Wood gives you 22. Carbohydrate like starch and sugar, they give you 16. You might say, sir, where is petrol? Okay, where is petrol? Okay, let's ask Google. Petrol kilojoule per kg per gram lah. Okay, so we divide by 1000. Petrol will give you 45. Petrol will give you petrol, the one you put in your car, petrol will give you 45. Which is less than oil lah. This is why gas is the best to use. This is why gas is the best to use, because gas gives you the most energy. So you know why we don't use wood? You might say, okay, you know last time those steam engine, you know steam engine? The one we used like 100 years ago, this thing, you know steam engine? This thing, the very 老牙, very 落后 one, the very old school steam engine. Last time train used this thing, right? What do they burn? They burn wood. You might say, sir, why don't we use wood leh? Because you see, wood sucks. Wood sucks because wood only gives you 22, right? That means 1 gram of wood gives you 22 kilojoule. That's very little energy. But if you burn coal, 1 gram gives you 34 leh. You get 50% more energy leh. Right? And this is why your car uses petrol. Petrol gives you 45. Right? Petrol gives you 45. So petrol is much better. So you see why we use fossil fuel? Do you know why we use fossil fuel? Because fossil fuel is your gas, your petrol, and your coal. You see, they all give you a lot of energy. That's why we don't use wood. Wood sucks, right? Okay, what about uranium? Okay, just to let you know, you know what is uranium? Okay, uranium, kilojoule per kg. Let's talk about uranium. Okay, uranium, how much are they giving? How many kilojoules are released from a kilogram of uranium? Okay, this is very hard to see. Wow, that's a very big number. Okay, that means if you use nuclear, you get like yes, radioactive. You get a few more thousand times. Oh, there you see, around 16.5 billion kj. That's a lot. That's a lot, right? Like, I don't know how many million times better. This is why you use nuclear law. That's why I always say nuclear is the best fuel. Nuclear is the best fuel. All right. Why is it okay for us to use nuclear to bomb people, but why is it not okay for us to use nuclear to make energy? You see, we live in a very funny era. Okay, like when the Americans say, "Oh, I want to make nuclear bombs to protect people," they say, "Okay, cool." But when you say, "Oh, I want to use nuclear to generate electricity," "Oh no, you can't do that. It's very dangerous." You see, so stupid. Why don't we use nuclear? Nuclear is the best. Nuclear is the best. All right, you see, all this sucks. All this sucks. You see, your sugar only gives you 16. Sugar it only gives you 16. So technically speaking, if you drink petrol, you get 3 times more energy. If you drink petrol, if you don't die lah, right? If you drink petrol, you'll be 3 times fatter. So if you say, "Oh, sir, I eat sugar, I cannot get fat," never mind, go drink petrol. For sure you get fat one, because you have so much energy there. I mean, whatever if you don't die lah. Okay. Still nuclear fuel from I don't think you can use nuclear to make car lah. Please, that's not very possible, right? Because one car crash, you have explosion, right? You have a mini nuclear bomb around you. Okay, so next, other exothermic process. So what are some other exothermic process? We have respiration. Okay, this fella is doing respiration when you're running, when you're doing exercise. Oh, look at how fit he is, right? You're doing respiration. So guys, respiration, can you see it's actually the same as combustion? It's sorry, this one. It's just that you change your fuel into sugar. You see, fuel plus oxygen, carbon dioxide, water, energy. Same thing here. Glucose, oxygen, carbon dioxide, water, energy. So what we do in our body, respiration, is actually the same as what you do in your car. Right? So all life processes requires energy. Living things obtain their energy from their food. You get your energy from your food. The process in which energy is released is called respiration. In this process, glucose reacts with oxygen. Okay, this one you already know. So the energy released in respiration is used to make substance inside the body, to make the body move, to maintain body temperature, etc. Mainly is to make you move. Okay, when you move, you are using energy. Okay, transportation using nuclear. I mean, possible, but it's quite impossible to mass produce, if you get what I mean. You can make one car with with nuclear, but you can't make a few thousand. You get what I'm trying to say? Right? You can't mass produce it. So that should be the concern. All right, so next, oxidation. What is oxidation? Rusting is oxidation lah. You see, this is rusting, right? Rusting is oxidation, right? So when a substance reacts with oxygen, it is called oxidation. This happens to your apple also. When you cut your apple, you put it on the table. After a few minutes, it turns brown, right? When it turns brown, this is what we call oxidation. Okay, so that's oxidation. So oxygen and water reacts with rusting is another oxidation. So oxygen and water react with iron to form iron oxide. This forms brown flakes of rust, which breaks off from the surface and exposes more metal to oxygen dissolved in the water. The iron or steel continues to produce rust until it has completely corroded. Right, guys? You don't really see rust in Malaysia. Got lah, but very few lah. Very few lah. Have you seen those cars in the Rust Belt? You know what is the Rust Belt? You know what is the Rust Belt? In the US, these few states are there, you see? Illinois, Indiana, Michigan, Missouri, New York, Ohio, Pennsylvania, West Virginia, and Wisconsin. These states, we call it Rust Belt. And if you buy cars from this Rust Belt, be careful. Because when you climb under the car, even after 5 years, your car will look like this. Right? You see, you don't see this in Malaysia. You don't see this in Malaysia because we don't really have a lot of. Okay, why do they rust so fast? Because these states, they snow, right? They snow. So to get rid of the snow, they will spray salt on the road. Okay, that's why they call it a salt belt or rust belt. So you get all this rust and your car will look like this. Right? Have you seen this in Malaysia? No, you haven't. Right? Our car, even like 30 years, you still don't see this one because we have no such problem. That's why if you live in a winter country, if you live in a snowing country, this is what you are facing. So this is exothermic, right? This is exothermic. That means when iron, they rust, the temperature actually increase just by a little. Okay, just by very little. Okay, cool, we have the very big. I mean, it's very beat up because of collision, because they crash it, right? But your Myvi is still not rusty, right? You don't see rusty Myvi in Malaysia, okay, very seldom lah. Okay, anyway, so the rest of it, reactions of metal with water. Okay, we learned this last chapter, right? When you throw lithium, sodium, potassium, you remember the group 1 crazy people? You throw them into water, they explode, right? So when they react with water, heat energy is released to the environment and the reaction temperature increase. You remember these crazy people? You throw sodium in water, they explode. You throw potassium, explode. So this is very exothermic. Okay, so reaction metal of acid. Okay, when you react metal with acid like hydrochloric acid and magnesium, you get exothermic. Right, guys? Guys, very fast exothermic, we call it explosion. Right? So explosion is just a very fast exothermic. Okay, you see, when you burn a piece of paper, right? When you burn a piece of paper, how long does it take? How long do you think, let's say you want to burn a piece of A4 paper, how long does it take? Let's say you start with a lighter. How long do you take to burn the paper? Maybe 30 seconds, 50 seconds, okay, around there lah, 30 to 50 seconds. But explosion happens in 0 point something second, right? So in your whatever explosive you are using, let's say you are using nitroglycerin, you are using dynamite, you are using TNT, they do the same thing. They do combustion, they do exothermic, but they do it in a very short time, so you get explosion. Okay. Hello, Adrian, 你还好吗? How's your internet? Okay, so guys, we finished our exo. Do you have any question? Do you have any question? Guys, you guys okay? You guys okay? Can you please give me a Y if you're okay? To make sure you are there. Okay, make sure you guys are not falling asleep. Okay, cool, cool. 在车上上课哇，这样勤劳哈你去哪里？Where are you going? Okay, cool, cool. Thank you, thank you. Okay, so you guys okay 吃饭哈okay, okay. So everyone is here. Everyone is here. Am I missing someone? Oh, Clarissa, are you okay? Clarissa, are you okay? Okay Are you there? Are you there? Guys, I know this is boring stuff Biology stuff is usually the most interesting one. Chemistry and physics stuff is quite yeah. Okay, so I will try to go through this quickly. Okay, so let's talk about endo. Let's talk about endo. Endo is when you absorb energy and the surrounding becomes cold, right? One of it is melting. You see, when ice melts, surrounding becomes cold, right? When your ice melt, your drink becomes cold. Okay, so once the temperature rises above 0, ice absorbs heat energy from the air and starts to melt. This is reversible, not a chemical reaction. Okay, and then what is a sherbet? What is a sherbet? Sherbet is a type of sweet that when you put it into your mouth, it feels cold. I don't know whether you have eaten this before, right? This is basically citric acid and sodium hydrogen carbonate. Okay, what is sodium hydrogen carbonate? This thing is your baking soda. All right. When acid mixed with baking soda, you actually get colder temperature. So when you put your sherbet in your mouth, it feels cold. This is due to endothermic reaction, heat being taken from your body. So you absorb heat away. So the reaction occurs when sherbet dissolves in your saliva and the two chemicals react together. So these two react together, you get sodium citrate, calcium, carbon dioxide, and water. And this thing, they taste sour. That's why sherbet, they taste kind of sour. Don't memorize this. Don't memorize this. This is just for fun. Okay, cooking. When you cook food, food absorbs heat. Like your egg absorbs heat and your egg turns solid. So that's your cooking. Endo also. Heating limestone. Guys, if you wanna, you can kind of focus on this. Because I don't know why your exam, they tend to like to ask this thing. All right, so limestone, by the way, you know what is limestone? This is called 石灰. This is called 石灰. This is your limestone. Hang on, someone disconnected again. Hello Jenny, how are you? Jenny, are you okay? You disconnected for quite long, right? Are you okay? Are you okay? How long have you disconnected? Sorry, I didn't know. I didn't notice. I didn't notice how long you were gone. How long did you disconnected? Oh, the Wi-Fi, huh? How long did you disconnected? Where did you I'm sorry, I didn't notice that you were gone. 6 minutes, okay lah, okay lah. Not too bad lah. Okay, so let's talk about this 石灰, we call it limestone. Okay, limestone is made from calcium carbonate. Okay, when you heat calcium carbonate, they will turn into calcium oxide and carbon dioxide. Right? All right. So okay, how does it work? Okay, calcium carbonate is CaCO3. When you heat it, it turns into CaO and CO2. Can you see the CO2 broke away from here? Next year you'll be writing this. Next year in year 10 chemistry, you'll be writing this. The carbon dioxide broke away from the CO3. The CO2 broke away from the CO3. So now you have O left. Okay, you might say, sir, what the hell is this? This is what happens when you burn limestone. So limestone, they absorb heat and they break up. So this is endo. This is endo. So calcium oxide is normally called lime. This thing is called lime. This thing is called lime. Not the lime. The lime that you eat. Sir, I thought lime is limau ice. You know, tail ice limau. No, not the lime. Okay, not that lime. Lime is a type of stone. Okay, and it's used to make bricks, plaster, glass, and paper. Especially your plaster. You know your plaster. You use plaster to put your ceiling. When water is added to lime, slick lime is made, which is used to neutralize acidic soil, to treat sewage, to make it harmless, and in food processing. That means lime, you add water, you will get something called CaOH2. This thing is your slick lime. Okay, slick lime. We use this to put in your soil. If your soil has all the acid rain, plants cannot grow, right? So you put your slick lime here. I think we mentioned this in year 7 already. Okay, just as a reminder. Okay, photosynthesis, same thing. Plant, they absorb energy from the sun. They make food. So this is endo also. Okay, so this is endo also. So guys, that's it. That's it for your endo and exo. That's it for endo and exo. Very easy stuff here. Very boring too. Okay, I know. All right, so guys, let's go to our exercise. Okay, if I'm going a bit too fast, you let me know. If I'm going too fast, let me know. I will slow down a bit, but it should be okay lah. So next, let's look at number 1. Fill in the blanks with endo and exo for each of the situations. So number 1, this is burning, right? Burning is exo. Okay, cause you get heat You burn wood, you get heat. So that's exo. So what is this? This is your photosynthesis. They absorb heat. They absorb sun. So this is endo. Okay, endo. And then what is this? This is respiration. You release heat. When you touch yourself, it feels hot, right? You are releasing heat. So the surrounding becomes hot. So this is exo. These two, they are the reverse. Have you noticed this? Plant, they absorb heat. You release heat. So endo and exo reverse. Cooking is endo because the egg absorbs heat. All right, and then firecracker, exo, because you release heat. Or just not absorb, sorry, did I just say release? This is absorb. And then melting is also endo, because the ice absorbs heat. Okay, simple, guys. As simple as this is, I still have students getting this part wrong on. So yeah, I know it's easy, but try not to underestimate this. Right? This is how you, when you get cocky and when you underestimate question, that's when you start to make mistakes. All right, so be careful. Right, B, define the following types of chemical reaction. What is endothermic? Endothermic is a reaction that endo is absorbed. A reaction that absorbs heat from surrounding. And then an exo is reaction that releases heat to surrounding. Okay, absorb, endo, enter, exit, exo, so release. So next, number 2, so you have exo and endo. This is exo, this is endo, because this is exit, this is enter. So determine whether the statement given is true or false. Okay, true or false. So ignore the Bahasa Melayu here. Sorry, this is a dual language book. So reaction X is exothermic. Yes, true. And then number 2, heat is released into the environment in reaction X. Do they release heat? Yes, they do. So true. Number 3, temperature of environment will decrease in X. That means surrounding becomes cold. No, surrounding becomes hot because I put heat out. Okay, so false. Number 4, the heat is absorbed into the environment in reaction Y. Okay, so I absorb heat. Yes, true. And then number 5, temperature of environment will increase in reaction Y. So will surrounding become hot? No, you stand beside, you should feel cold, right? Because this is cold water. So this is false. Okay, guys, it's just differentiating left and right. Okay, it's just differentiating black and white. You either have black or white. So don't confuse. Don't confuse left and right. Okay, next, number 3. So you have endo and exo. Endo is absorb heat, so exo is release. Surrounding temperature increase, surrounding becomes hot. This one, surrounding will decrease. Surrounding becomes cold. This one you don't need to know. Change of energy, heat to chemical, chemical to heat. This one you can don't care. Not really important. Okay, next, B. How many questions do we have? I'm not going too fast, right, guys? I'm not going too fast. If I am, then please slow me down. Don't be shy. Okay, next, to study a chemical reaction. Okay, guys, when you see ammonium chloride, right? Whenever you see the word ammonium, this is definitely endo. Definitely endo. Okay, guys, just to tell you, 90% of chemical reaction is exo. 90% is exo. You have that 10% of endo. So endo is quite rare. Endo is quite rare. It's only during just now the chemical, the sherbet, the candy you eat, only that, which is the baking soda. And whenever you see something ammonium, or whenever you see something nitrogen, please write down. Whenever you see ammonium or nitrogen, you can almost be sure they are endo. They're just funny, right? They're just funny because instead of releasing energy, they just like to absorb energy. So what will happen when you add ammonium chloride? At the beginning is 24, the water is 24. Now this thing will turn maybe to 20. Okay, I mean, you might say, sir, I can't change to 5, man. Okay lah, not so 夸张 lah, not so 夸张 lah, not so crazy lah. Even this is endo, right? It will be a small endo. The temperature will drop by just a little bit. You want to say 15, I also can one. but 15 is a bit too much lah. 20 sounds fine. Okay, you just have a few degrees change. Okay, so explain your answer. Okay, why does this happen? Because the reaction is endothermic. It is endothermic because I absorb heat from surrounding. Okay, easy peasy. Next, number 4. Rizwan and his friends carry out an experiment. They mixed water with substance PQRS in 4 beakers and recorded the temperature reading. So this is the result. So for beaker A, B, C, D, we have 4 different beaker. So he puts PQRS. So for P, temperature drops. So this is endo. All right, I like to write this on the question first. For Q, temperature increase. So you see from 28 to 29.5. So this is exo because surrounding gets hot. Then 29 to 31.5 also exo. 29 to 27.5, this is endo. Now we have 2 endo and 2 exo here. Guys, don't get this in reverse. I have students for some reason in exam they just get confused. They just reverse the thing. They thought, oh, sir, cause temperature decrease Temperature decrease temperature decrease means I release heat So exo lor. No temperature decrease means I absorb heat surrounding gets colder. Don't get confused right? Because I have quite a number of students, they will get confused in exam right? So what can be observed by Rizwan explain? So you can say for P and S, okay, for P and S, temperature decrease. For Q and R, temperature increase. Okay, don't write like this in exam I'm just lazy. You already know. So B, based on the observations, Rizwan made 2 inferences. What is inference? Inference means to explain Why do you see this? State 2 inference and explain. Okay, so why PS decrease? Because for P and S, they are endothermic reaction. Okay, they are endothermic. So heat is absorbed. 2 marks. What about the other 2? You reverse law. So Q and R, they are exo. Heat is released. That's all. All right, 4 marks. I don't think your school is generous enough to give 4 marks in such an easy question lah. So I think 2 is good, right? I think your school will give you 2. Okay, that sounds more like it. Right? I mean, some of you learned this last year already lah, so I'm not gonna bother you with this. Right, so number 5, please don't tell me you don't know how to read temperature. So this thing is 28 degrees to 30. Does it look like 6 or 7? This one. The middle, Okay, let's just say 30, 37 lah. Looks like 36 to me. Okay, 精彩 lah. Okay, so I see ammonium again. This one for sure decrease lor. It goes from 29 to 20. Oh my god, I can't draw this properly. Is it 25 or 26? Okay, let's just say it's 26. Wow, so close. Right, so explain the heat change in the both experiment. Experiment 1, what is happening here? They want the heat change. That means heat is what is happening. Okay, so for this, heat is released. Okay, I put out heat to the surrounding. For number 2, you see temperature drops, right? So now heat is absorbed. I absorb heat. Okay, I absorb heat, so my temperature drops. Wow, so boring, isn't it? Sir, can we talk about something else? No. Unfortunately, this is what we have to talk about today. right? So when we heat calcium carbonate, you will get calcium oxide, and you will get carbon dioxide, right? So how do we know that there's carbon dioxide? How do we know that there's carbon dioxide? We put something called lime water. Oh, this one you don't know, ah? Do you know what is lime water? Do you know it's lime water? Okay, lime water, originally, they look clear. They should look like normal water to you. But when you have, no, not sour. That one is limau ice. Okay, no. Lime water is 石灰水. Water with plaster inside. All right, like your ceiling water. Okay, I don't know how to explain this. Okay, so you see, lime water is originally clear, but if we have carbon dioxide in it, it will turn. Can you see it turns dirty? This is what we call cloudy. This thing will turn cloudy. When it turns cloudy, you know there is carbon dioxide. So this is lime water is used to test carbon dioxide, whether they are released or not. Okay, so is the heating exo or endo? Okay, this is definitely endo. Why? Because this thing will absorb heat. Okay, because your calcium carbonate absorbs heat. Sorry, absorbs. Okay, absorbs heat. I'm just going to give you 2 marks for this. I'm not going to give you 3 because it's too much to explain. So it will absorb heat. This thing will absorb heat. All right, next, when we burn magnesium, did a chemical reaction occur? Yes. Because heat is absorbed by magnesium. You see, when I burn magnesium, the magnesium will absorb the heat. So this is a chemical reaction. Whenever there's a heat change, it is a chemical reaction. Okay, so what conclusion can be made from this reaction? So magnesium is reactive, yes. If you remember, we used magnesium to make camera flash last time. It's very bright. The reaction is exothermic. Okay, you see at the beginning it is endo, but when it starts burning, it is exo. So I don't know whether should I put this exo or endo. It will first do endo, then do exo. I don't know if you get what I mean. When I first burn magnesium, magnesium will absorb the heat, right? So that is endo. When the magnesium starts burning, the magnesium will release heat to the surrounding. So that is actually exo. So it will first do endo, then do exo. So okay, let's just call this endo lah. Sorry, exo, I mean exo. Okay, so I have 2 ticks here. Right, so number 7, you know what is this? This is a heat pack. You know what's a heat pack? The thing you use to warm your hand. That's what we call a heat pack. This is a hot pack that functions based on a chemical reaction. So table below shows the change in temperature for chemical reaction PQR. So I have 3 chemicals here, PQR. P, they increase by 5 degrees. Q increased by 3. So this is 16. I don't know what they're asking this for. So this is 15 to 25. This is 10 degrees. So what is the final temperature for X? This is 16, easy. Name the reaction that release heat. This is exo. Wow, so boring. Okay, which of the following is suitable to be used to make a hot pack? Among PQR, if you want to make a hot pack, which one would you choose? Which one would you choose? You want your hot pack to be as hot as possible, right? So you will want to use R. You wouldn't want to use Q because Q is really shitty. You only get 3 degrees here. All right. So why? Because it releases the most heat. Okay, it releases the most heat. Or you can say it is the most exothermic. It is the warmest. All right. So instant heat packs are often used to heat up the body in cold climates or to treat certain injuries with heat. When the heat pack is pressed, it becomes hot. What is the type of reaction? Oh my God, again. Exo. So, okay, guys, how heat pack works, how heat pack works, inside here, there is a sort of like a how do I say this? There's a divider inside. Okay, there's a plastic divider inside. So here has chemical A, here has chemical B. When you press it, you break this thing, A and B will mix together, and they purposely will use two kinds of chemical. When you mix, you will get heat. You know those 懒人火锅, those lazy personal hot pot, 懒人火锅, it's like a thing in China. You have your own self-made hot pot one, no need fire one. You just put the heat pack inside water, the water will start boiling, and then you have now your own hot pot. The thing lah, the thing they use hot pack inside. That's how it works. All right. So you can say the, what do you call that thing? Let's call it a diaphragm lah. Okay, the diaphragm in the heat pack breaks. Diaphragm is this thing, is this layer here. So the diaphragm breaks. So chemicals in the hot pack mixes and release heat. So the A and B mix, you get heat. Very simple. Okay, wow, ngam, we finish at 8. And there you go, we finish our chapter 5. Okay, guys, sorry to bore you with this chapter, but this is actually what we, according to your Cambridge syllabus, what we should do. So next week, guys, we will go into chapter 6. This won't be that easy already, because reactivity is kind of challenging, because you have this thing to memorize. Okay, 6A for a while. Yeah, sure. 6A. 6A. Which one is 6 again? 6A. This one. This one. Okay, so you guys have any question? You guys have any question? You guys following so far? Okay, I hope it's a yes lah. So I think that's it for today. So I will see you guys the same time next Tuesday lah. Okay, so have a good one, guys. Good night to you. I will see you next week. All right, so take care, guys. See you. Bye bye. Bye, guys. Bye bye.